Hi, everyone. In today's talk, I'm going to talk about how to optimize your operations and reduce your cost using AI. However, I'm not going to show like a theoretical cases, but I will talk about use cases that we implemented at InstaDeep for our clients. However, before I start, I would like to ask a question. First, why AI? Why artificial intelligence? Well, the first thing is that artificial intelligence now is a necessity. Now it's going to transform every industry, just like electricity did 100 years ago. And the second reason is that between now and 2030, it will create an estimated $13 trillion of GDP growth. And the third reason is that it's going to transform all the sectors, not only software sectors. Well, now that we know the importance of AI, so how could you start as a company? How could you start your journey in AI? Well, you have 5 steps. The first one, you need first to start by executing pilot projects, just small projects, not very big projects. And then you need to build an in-house AI team. Then you have to provide a broad AI training for the different teams in your company. For example, for the executives, they will need specific training. Then your AI engineers also will need, for example, an extensive training of hundreds of hours. Then you need also to develop an AI strategy for your company. And you need to develop also internal and external communications. So we at InstaDeep, we accompany all our clients in all of these steps. So who is InstaDeep? So InstaDeep was founded in 2014 and is headquartered in London. So we are based on 3 pillars that differentiate us. First, we work with top-tier clients. We work with BioNTech, Total, Deutsche Bahn, and Google. And we have access to top talents in university, and we are funding different programs. And we have a lot of people from these different universities, MIT, École Polytechnique, etc. And also, we are doing cutting-edge research. We have a collaboration with DeepMind. We published papers together. We have 5 developer experts from 170 worldwide in machine learning. We are NVIDIA Elite Partner, and we have been elected 2 times in the top 100 AI startups. And actually, we have 6 offices in UK, Paris, Tunisia, Nigeria, South Africa, and Dubai. And we have also our own products. So we don't only do consulting, but we also build our own products. So how does it work? We have our decision-making platform that we use with the domain expertise, for example, for DeepChain, which is the first product, and used to design new candidates for cures, cures and vaccines. And it's actually deployed online. We have also a DeepPCB, which is deployed in beta version, and we are going soon to deploy 2 other projects, which are DeepPack and DeepRay. And as I said, also we are an NVIDIA Elite Partner, and we have our own servers and NVIDIA DGX GPUs. And we also worked with many big clusters like the Pangea 3, which was in 2019 the biggest commercial cluster in the world. And yeah, so now I'm going to talk about the use cases we did with our clients. So I will start with use cases with Total. So the first use case we started with Total is accelerating an algorithm called the local thickness algorithm. So how did it all start? So Total told us we have an algorithm that takes more than 10 hours to run on CPUs. And this is too much for us. We wanted to run, could you optimize that or find a way to do it? So what we did, we took the code, we transformed the code that works on CPUs to work on NVIDIA GPUs. And at first, so we reduced that to 1 hour, from 10 hours to 1 hour. And it was on a single GPU, I mean a regular GPU for gaming. which costs us only like $200. And so we ported the code to the DJX, and we were able to optimize the code to run on 8 minutes. So from 10 hours, 30 minutes to 8 minutes only on 8 GPUs on our DJX class. Then we worked on different other projects for microfossils semantic segmentation. So we started in the first phase with the 2D segmentation. We found we had good results in the 2D image by image or layer by layer. But when we concatenated the images, as you can see on the left here, we didn't get good shapes for the microfossils. So what we did, we went in phase 2 to 3D semantic segmentation, and we obtained better shapes for the semantic segmentations. However, Total wanted better results, and they wanted to detect each fossil apart, and wanted to know what's its category and its volume, etc., and wanted to have the count of the microfossils. And here we implemented that using 3D instance segmentation. And actually, for example, finding all these fossils in a single scan like this one would take a geologist like a month of work. A month of tedious work. I mean, labeling each fossil in the pixels of each fossil in only one single scan. And now you can obtain, I mean, all of these microfossils and this result on a 3D scan on like 40 minutes only instead of a month. And after that, we went to another project. So after we were able to detect the microfossils, they wanted us to generate them actually. Because what you see here, for example, this is the training image here. It's a 3D scan. So the scan you are seeing here, it's from a cutting that they obtain when they are drilling. And this cutting actually is very small. I mean, it's a few millimeters. And the problem is that their 3D scanners and all the 3D scanners in the world that provide such high resolution, they do not accept you cannot put a big rock like this one and put it in the micro CT scanner. So they take only some samples, some very small samples. However, they needed a big scan to run like the porosity, permeability, and different physical characteristics to test them. So they wanted a bigger sample or a bigger scan. So what we did, we took the training image here and we created a deep learning model called GAN, Generative Adversarial Network. And actually, so this model, it was created by NVIDIA actually. It was invented by NVIDIA. So we took it, we re-implemented it from scratch, and we converted it to 3D. And we did some modification to it so that we can generate bigger scans, not only generate, I mean, similar scans like this one, but bigger ones, like you can see in the picture here on the left. And when you zoom in this scan, you can see that you will find the same types of microfossils in here. And actually, when we run the different characteristics, they did their studies on these scans, we obtained the same characteristics from both generated scans. And then, so these are the projects we did with Total. We are also working with BioNTech on drug discovery. However, I cannot talk too much on that because it's classified. And another client is Deutsche Bahn, which we are working with. And actually, with Deutsche Bahn, we are working on the train scheduling. So they have more than 10,000 train rides per day, over 33,000 kilometers of railway. So imagine in case of an accident or in case of a delay, they have to do everything manually, I mean, to get back to work. And this is very tedious, actually. So the idea was to implement deep reinforcement learning. So the advantage of deep reinforcement learning compared to other optimization techniques is that the other optimization techniques, it takes, for example, a few hours to reroute all the trains, etc. It takes a lot of time. While for the deep reinforcement learning using AI, you train your model only once, and then it will instantly give you the results. So we are working on deploying this solution over all Germany. However, for now, we deployed it on We deployed it on 2 towns. We are testing it on 2 towns, and what you can see here, for example, in the flat map, in the flatland map here, it was trained actually before on a smaller map with 15 trains, and here it could generalize on a way bigger map. And now, as I said, so we are testing it in 2 towns in Germany, and it's deployed there. And so in the next few years, we are willing to deploy it on the whole Germany now.